Okay, so hello everyone, and welcome to another video on O-level physics waves. And today we're gonna do the category of waves. So as you guys know that waves are categorized in two different ways. One is the transverse waves, and another one is called the longitudinal waves. So let's proceed to what transverse and longitudinal waves are. So as you guys can see, transverse wave. And what really is transverse wave? It's in transverse wave, basically the direction of vibration is perpendicular to the direction of wave. Now, for that, I have an example for you guys. Now, what if I throw a ball in the water? So, as you guys can see, the ball is oscillating and it is creating a transverse wave. So, I would say that, as you guys can see in this, that direction of energy transfer is going on the right hand side. When the ball is oscillating, it's basically creating that sinusoidal wave, which is the transverse wave. So as you guys can see that in this wave, we have two things to majorly see. Uh, First one is on the highest point of the wave, you guys can see a crest, and similarly on the lowest point of the wave, you can see a trough. So the wave also comprises of crests, which are the highs of the wave, and the trough, which is the lows of the wave. Now, one more thing to show you guys an example of waves, that all the electromagnetic waves like X-ray, UV ray, infrared ray, gamma waves, microwaves, radio waves, and the light waves. The waves, the seven waves we discussed in our previous lecture as well. These are the example of transverse wave. Also, the waves that are created in rope, the waves in the water, are also an example, a prime example of transverse wave. Okay, so here we have another type of wave, which is the longitudinal wave. Um, in longitudinal waves, you guys can see waves in which direction of vibration, like from the source or the molecule, is parallel to the direction of energy transfer. Now, I can give you a prime example. You guys have seen the speaker. Sorry, my drawing is a bit weird for this. As you guys can see, that this is a speaker, and when it's turned on and the music has been played. So whenever you guys will see a speaker, just test it by putting your hand above it, and the curtain of the speaker, basically that thin curtain of the speaker, is moving back and forth. It's going right and left and like forward and backward, forward and backward. This is what showing that the source is parallel to the direction of energy transfer. As you guys can see in this picture as well, the wave is exactly the parallel of the red line. Under that red line, the direction of energy transfer is written. It is parallel to it. Okay, so let's check what longitudinal waves comprises of. So the longitudinal waves comprises of the first is compression, and then you guys can see a rarefaction, and then again you can see a compression. What is compression? Whenever the waves are getting compressed, you guys can see those longitudinal waves getting are like binded together, and then at a certain point they aren't binded. They're just having space between them. That exact part is known as rarefaction. So then again you guys can see that it's been compressed. So it is very important to know that longitudinal waves also comprises of compression and rarefaction. Now, what compression is really? Compression is also known as the higher pressure zone, when the molecules are close to each other. As you guys can see, when the wave is like close to each other, the source or the molecules are like closely binded towards each other. it's creating a high pressure zone, so that's why it's called as compression. Whereas the rarefaction, it is known as the low pressure zone. When the molecules are far from each other, they create a rarefaction, also known as the low pressure zone. And as you guys can see, when the wave is not binding together, it's having space between different waves. It is when it is having a low pressure over the molecules, and it's called as rarefaction. The prime example of longitudinal waves are what the sound waves are. Sound waves are the prime example of longitudinal waves. Alright, so I hope you guys clearly understood today's topic on the categories of waves. If you have any confusion, feel free to revise this lecture once again. Also, just a reminder to our O-level physics crash course is starting from the 1st of February, so make sure you don't miss that. I'll see you in the next lecture. Take care and keep practicing. Goodbye.